The interesting thing, if you compare that middle set of bars, which is 6-month post-training, with the quote unquote, they called them elite bodybuilders with 7 years of training, their fibers are the same size. Well, how is it that the elite bodybuilders have arms that are, let's see, it's 3.5 inches bigger? If their fibers are the same size, well, they probably have more fibers.
What do we want to start with? Do we want to start with the big thing that you had been doing a bunch of research on today? The question about genetic growing muscle, that question?
Yeah, we can. I didn't have to do a bunch of research. I just found some things I knew about.
You did a lot more than me. Okay, let me put it that way. All right. This is from Brian. Brian is one of our longtime listeners. I wanted to give him a shout out as well because he always comments with thoughtful things, and which of course comments themselves, so they help to boost the show up. So I appreciate his support with all of our shows, and I appreciate that he's getting something out of them. But he said, question for the next episode. Over the years, I have seen multiple examples of absolute freaks who have that one muscle group that just does not respond like the rest. Marcus Rule's triceps, Ronnie's calves, and so on. These guys are the best of the best, but when it comes to growing muscles and with the best genetics in the world, what is it about those weak muscle groups that just will not grow despite being exposed to all the training and supplements in the world? Thanks.
Okay, so this is a potentially. There's so many different tangents we could go on with this. I think with those two examples, I've got the first thing that comes to mind. You don't have to go into any deep muscle biology in order to piece this together. I have the suspicion that maybe Ronnie's calves were better, and when he was younger, you may be able to find pictures, and they started to degrade. Yeah, they weren't always like weak. He had good calves. But I think he may have torn them. Like I've torn mine. I've torn my right one. There's no medial gastroc there. It's gone. Yeah, because I tore it. I never felt any pain. It just felt this little bit of a snap, and over time, it just degenerated. People sometimes get bad shots, and they get nerve damage because of that. I know of multiple examples of that. If you look at Dennis Wolf's calves, they sort of went downhill over time. And there's been a couple people. Yeah. So it may not be simply what he's kind of asking about is like, why didn't his calves grow so well? It's that maybe they weren't that bad. And when you saw them at the end, when everything else was fully maxed out, the calves had a different history of being torn or being maybe he did some shots in there and had an issue with it. The same thing makes me wonder about Marcus. You never know. His biceps are still huge.
Yeah.
Like if you can, like he's very active in the German bodybuilding scene. He does like videos all the time. It's funny because there's a lot of guys. You know this phenomenon. Well, when someone wants to make themselves sort of a little more famous and get more views, they invoke the name of someone who's much more famous than they are, so they take a pot shot at him or whatever. So people take pot shots at Marcus all the time. There's all these back and forth videos. They're in the German language, but of like, Marcus saying something and this person saying something back and forth to one another. It's ridiculous. But his biceps. So he trained with Urs Kalesensi, I think that's how you say his last name. The German guy. He's originally from Poland, who was. I think he was 4th in Olympia.
Okay.
In the classic physique, he's the best German bodybuilder out there now. Potentially, placing wise, recently he's maybe even better than Roman Fritz because he's just placed better than Roman has in his category.
We'll see how Roman does. Roman's coming your way, I think. I don't think it. Okay, I was gonna say I didn't think it was a secret or anything. Yeah. No. He's made that known now. Yeah, I can't go to the Tampa. I don't think I can go to the Tampa Pro. I think I can get there. Bummer. Oh, that's right, because you're not in Tampa. You're nowhere near Tampa. No.
I'm 3 hours away, and I've got my RV, but Suki's got limited. She's got a cone on her head now, and
he's looking good though. So we'll see if he changes that. We'll see what his placings look like after this. After a couple good shows.
Yeah, finally. because he was putting down. So he does lots of his videos in. We're getting off topic now, but he does lots of his videos in German, but lots of them in English as well. And he was putting down like 8,000 or 9,000 calories in a day during an off season.
And he stays so lean. I feel like he's a guy that needs to be able to force food like that. You know,
that he had to. Yeah, he wasn't going to get any bigger unless he went all in like that, and he did.
Yeah, that's cool, so, and it's paid off, man, because he's looking incredible right now.
Yeah. So
anyway,
so back to Marcus. If and I'm not saying that he did or he didn't. People accuse him of this naturally. If he was putting something in his biceps, that's a much easier muscle to shoot than the triceps for size. So, and if you run into an issue, if you're doing this on your own, let's say you're doing SEOs or doing local injections and you develop scar tissue, like I know there are people shoot their biceps as much as anywhere else. They just like to put stuff there.
Yeah,
it's very easy. Yeah. The triceps is a little bit harder.
Yeah.
Try to inject in your triceps. And because of the difficulty in doing that, you may actually cause muscle damage. So that's one possibility. Like you've got the injection and muscle tear history potential of the person. So also how a muscle grows over time is a function of its loading history. That's kind of the fancy term for how much does it get used during the day? Has it been trained? Has it not been trained? You, for instance, you're an example of just the opposite of this phenomenon in a certain way, because your calves are friggin' world class and they outpace. Yeah, your calves are ridiculous.
Yeah,
and then you've trained them. They're super ridiculous. You train them. We talked about this multiple times. You sent me that. I'll never forget. You sent me the video of just looking at your feet while you're doing side laterals and you're up on your tippy toes.
Yeah.
So you've got this loading history, whatever it is about the way that you learned to locomote as a kid.
Yeah.
Probably some of it has with your biomechanics. Maybe there's something in your environment, like maybe you need to see up over tables or something like that when you're a kid. Who knows? But that's the way. You don't have much of a heel strike, and so you've got tons of loading on your plantar flexors. You had a loading history from the get-go early on of just loading the hell out of those calves.
Yeah.
And there's some potential. I haven't. People talk about when new muscle fibers would form or when muscles grow, but there are periods early on in development. We know this especially from the animals, that you've got satellite cells that are particularly involved with potential to create more muscle fibers. So you may have been doing that as a kid or early on in a way that led to larger. It'd be interesting to see how big your muscle fibers are versus what you could kind of use it as an estimate of how many you have. You may have normal sized muscle fibers,
but more of them,
or not terribly large, but a lot of them.
Yeah.
So there's all of that in the loading history that can play a role. So what the calves undergo, this is why people train calves differently compared to what the biceps undergo, can be completely different. Biceps are, you're not doing much with them. If you're just training and you're doing nothing else but like writing and maybe working at a keyboard, you've not got much going on there.
Yeah.
So what you do, if you look at the loading history of when you're training during the day, and let's say you do, let's say you do 10 sets for a muscle group in a week, something like that. And each of those sets is a minute. You spend 10 minutes once a week. So add up the hours, 7 times 24 versus 10 minutes. So like 1/6 of an hour versus 148 hours or whatever that is. No, 188 hours in a how many hours in a week? 24 times 7. A lot. So it's a very small. Yeah, someone's going to post it for us. Yep. So the very small amount of time is actually spent doing the training. And you see this phenomenon in the other animal models of hypertrophy, the compensatory hypertrophy, which you talked about. They take out one muscle group of the calves, take out the soleus, and watch the gastroc grow. Mm-hmm. It'll do that. One thing you tend to see for instance, in older people is that the leg muscles will atrophy more so than the upper body over time compared to younger people. So that's what you see in older people is they don't walk around as much. They're not as active. Their step counts go down as they age. So you've got this loading that's going on in the legs that progressively changes, and you lose size there. Whereas in the upper body, people do. You'll even see the way people like they'll lean against things with their upper body, like literally if they got a bad back or what have you. And most of Americans after the age of 40 have a bad back. So you've got this little change in the upper body loading history. You have much less loss of muscle mass, whereas you stop walking around so much and squatting. You get bad knees. What do? You don't squat down.
Yeah.
You bend at your back, and you're not doing anything that's close to what a stiff-legged deadlift would be or a deep squat would be. You lose size there. Mm-hmm. So there's all sorts of accommodation that can happen. People just don't move around in the same way. They don't get the same loading history that's going on all the time outside. You look at tennis players, and you think of a tennis player playing being like the way to build a big arm, but tennis players have a bigger arm in their dominant arm than the other ones considerably.
Yeah,
it's fairly.
I've seen that. I remember seeing Roger Federer and just seeing like a huge discrepancy. In fact, I'll look post-production to see if I can find a picture that would demonstrate it. But his right arm, or I think it was his right arm, I believe he was right-handed, was muscular, and the other one almost looked atrophied by comparison.
Mm-hmm. So there's those things, and then there's also like, what does someone? Who knows? If we look back at Marcus Rule, he used to do crazy heavy pressing. Maybe he constantly used to go really wide on his presses.
Okay.
Have you ever seen, like, he's got in the what's the name of the video? In the main video that he had, I'm blanking on the name of it, but he's doing like Smith machine presses, and his hands, you can't see me because there's not a room in the camp, but his hands are literally like almost as wide as they can be. His range of motion is very small.
Yeah.
He's got like 5 plates on the Smith machine.
That's wild.
But it's crazy. Yeah. So he may have had and so that doesn't favor a good range of motion for the triceps at all. So if he did a lot of his presses that way, he's not getting tricep loading that way. Some of that may have been because maybe he had chronic triceps tendonitis. Some people tend to get tendonitis in the knees or in their elbows, either in the hamstrings or the patellar tendons on both sides of the joint. So that's going to limit direct training there. So there's a lot of things that are involved, or that could be possibly involved, as to whether one muscle grows versus another. The thing that's interesting, too, is this whole story with satellite cells. So we've talked about this. Satellite cells are just outside the muscle cell membrane, and they're waiting. And this seems to be important. I should have gotten one of these figures, but if you look at what happens in those who grow really well, who gain in size really, really well, versus those who are non-responders or just moderate in terms of their response, there's kind of 3 things that happen, at least, in terms of satellite cells. One, the people who respond really well in the muscles that they've tested have more satellite cells available in the first place, just born with them. They also have an increase in the number of those satellite cells and in the density of those satellite cells. So the satellite cells proliferate themselves, and they're ready, because when a muscle cell gets bigger, it needs more nuclei. The cell's so big, it has to have multiple nuclei. You can't just grow and grow and grow. So there's some mixed evidence here. Some of it depends on the muscles that are being sampled. But satellite cells are important, and the growth factors that turn on the satellite cell activity are released in larger amounts in those people. So the interesting, we can start comparing muscles. You generally see the muscles, like the muscles of the diaphragm, which has a totally different loading history. Diaphragm's always going.
Yeah.
It's like your heart. It's constantly there.
Yeah.
The satellite cell activity there is different than what you'll see, for instance, in a calf muscle or a quad muscle, or a biceps or a triceps. So, and also, if you look at muscles and here's what satellite cells are so fucking cool. Look at muscles, at least in animals, that have like a lot of a type 2 fiber type, and you take those satellite cells out and you put them in culture, and you can get them to turn into regular muscle cells. Those will tend to become type 2 muscle cells.
Okay.
So they're not completely undifferentiated. They can't just turn into whatever. They pick up on the local environment or what that person's genetic proclivity fiber type wise happens to be. They've done studies with, this is one of my favorites. I mentioned this before, I think. They've taken endurance athletes and compared them with control people who are sedentary. And they take a little muscle sample and they pull out and they take these satellite cells. So the satellite cells are just sitting there. They're not muscle. They don't contract. They produce no force. They do no exercise. They're just hanging out, like saying, okay, see what's up. Like, tell me what I got to do. What's next? And I'll be ready for whatever adaptation is impending. They take out those satellite cells from the trained individuals and develop those, prod those into development with growth factors into functional muscle cells. It's in a culture dish, so it's not connected to anything. And then they look at the insulin sensitivity, which we know is improved by exercise, in those satellite cells that have never exercised. And they have better insulin sensitivity compared to the control people who weren't exercising. So the satellite cells are aware they're picking up on the metabolic demands or picking up on the nature of the loading history of the muscles that are there. And they also are aware of what fiber type they come from. So you've got the story of if someone's, for instance, born with lots of type 1 fibers in a muscle for whatever reason, that maybe is one that tends to be a little bit stagnant to growth. It doesn't want to grow very well. It's a weak muscle group. You're going to have satellite cells in there that want to become type 1s. Those don't grow very well. So let's say you get 20% growth in the type 1s and you get 30% growth in the type 2s. If you got a muscle that's mainly type 1s, you're stuck with those in terms of the growth you get there, and the satellite cells aren't going to help you out too much. So there's that. And let's start pulling up some of these figures because now there's all sorts of cool shit here. Let's see which one is the best one to start with. Let's see. Which was the first one? Which one did you have there that came over to you first?
The first one is the one that says 2006. And then the one...
Yeah.
That one?
Let's pull that one up. Yeah, why not?
Right.
Why not? Let's see what you got. All right, so there's very little data here, but it's all over. It's somewhat mixed. It's kind of interesting. So in that first the bar graphs up top, that's from the study from Italian researchers published in 2006. And what you see on the left is the difference in the cross-sectional area of the vastus lateralis in particular and the quads. So the open bars are the control individuals, untrained, and the bodybuilders with at least 2 years of training in this case are the grayish bars. So their muscles are bigger. If you look to the right, you see the distribution of the myosin heavy chain. So that's basically how much of what fibers do they have. In this study, if you look at that first set of bars there, where it says MHC1, if people can see that, it's in the upper right. You got a scenario here where the bodybuilders tend to have more type 2 fibers, which would be a good thing because type 2 fibers tend to grow more. So that's interesting. That's fine. That's one finding. If you look below at another study, in this case, you can just look at that rightmost column, MHC1, myosin heavy chain 1. And the numbers, the means there are for competitive bodybuilders, and then just recreationally resistance trained, an endurance rower, and then the control. And what you see there, if you compare the competitive bodybuilders with any of the other groups, really, but resistance trained, you see the strongest difference there. There's a tendency there. You can look at all the values. There's a tendency there for, in this case, in this study, with these people, when they sampled the triceps, not the quad, not the vastus lateralis, but the triceps brachii, so the arm muscle, the competitive bodybuilders tend to have more type 1 myosin. So the muscle, potentially, you compare these two studies that you sample, is going to give you a different picture in terms of what's happening. And of course, your quads, like there's a guy, I think his name is goes Bulldog, something like this. I found him somewhere on maybe Facebook or could have been YouTube. I follow him on Instagram now. He lives in Texas, and I think he was born without legs, so he does everything with his upper body. I posted a kind of a motivational video from him the other day, 3 weeks ago maybe. And he walks around on his arms. He doesn't have any legs. And he's like, he's got the state record by far for a bench press. He can bench almost 500 pounds.
No kidding. Wow.
But he has no legs, so it puts him in a very low weight class. But he's friggin' jacked. He has a national level, if not a pro level upper body.
Wow.
From a bodybuilding standpoint. He's a beast, and he's potentially part of why he's so big is because he's been using his upper body like that so much.
Yeah.
Yes, but he started that way as a kid. If I remember the story correct, maybe he was very young, or maybe he was just born without these legs. I think maybe they had been amputated when he was very, very young. I can't recall exactly, but so imagine if you had to do the same relative effort level and work with your arms that you do with your legs during the day. Yeah. Your legs you're paralyzed. I've seen guys who've had spinal cord injuries who have done everything they can to become able-bodied. It's the same scenario. Mm-hmm. So there was a guy who used to go to the Shepherd Center, who had he drove. He had a special setup on he was lower body spinal cord injury. Mm-hmm. And he drove. He had a special setup so he could just use his hands for the brake and the accelerator and to steer. And but he had a chair too that he used. But he was one of those guys that he put himself. He could get on, buck himself in on the chair and get on a rope and pull himself all the way up. And he had a Jeep. He would park his Jeep, and his wheelchair was in the back of the Jeep. Yeah. And he had a frame, a rack in there, may have been custom made, and he would literally get out, climb around like a monkey swinging on trees, climb around and just hand his way over there. And with one hand, he reach in and grab his wheelchair, put it on the ground, flip it open, and then swing himself down, land to the thing.
Holy shit!
It was like his gymnast. It was amazing. Yeah, and his upper body was just jacked. It's huge.
One big muscle.
Do the same thing in gymnasts. Yeah. Huh. So there's multiple ways to get to hypertrophy, and this is one kind of more direct answer to this question because there's so many cool little bits and pieces to this story. Is that if you have someone, and we don't know about Ronnie or there's those other possibilities of injections or what have you that may explain the differences in why Ronnie's calves maybe got worse and biceps were better for Marcus and his triceps. But if you have someone who's genetically gifted, who does really, really well, like whatever they do, they tend to grow much better than the average person right out of the chute. They're really so they don't have to do the trial and error necessarily that someone with more mediocre genetics has to do. Yeah. So it may be that they would have to train their calves or the weak muscle group in a different way, and they never get around to that. And we're going to see those people who are prominently, like really amazing bodybuilders with one sort of missing body part more often.
Thank you for tuning in to another podcast here at Think Big Bodybuilding Media. If we've provided value to you today, then please consider contributing to our show. You can help support the show through Patreon. Every $5 helps to pay for the software and the hardware and everything else that goes into making a podcast. You can also contribute by using our code at True Nutrition. True Nutrition has been our title sponsor for several years now. I'm super grateful for them, and I've believed in True Nutrition supplements long before they sponsored our programming. You could use our code THINK for health supplements and performance supplements. Feel free to hit me up if you have any questions. And if you're in Canada, check out supplementsource.ca. They have free shipping over $99, huge discounts on overstocked, short-dated, and label-changed products. Plus, they have all your normal supplements too. Thank you guys for listening to the commercial. I hope you're having a great day and that your bodybuilding is going well. Let's get back to the show.
Because they're so good, and then it's even more glaring when that is there.
Oh, yeah.
But because they're so good, because they're so good, then they don't do the trial and error that most of us have to do in order to figure out what works. And it can be all over the place. So we've got the muscle that's involved, the satellite cell density that's there, which can vary what's happening over time with those, depending on the loading history of the person, how they locomote, like you walk around on your tippy toes all the time, for instance. There's so many things that can go into this. So here's let's see what the next thing I have here. So this is an interesting one. There's this other part of the story. If you pull up the next thing I sent you, I think it has McDougall written at the top.
Got it.
So let's take a look at that. So this is kind of a cool study. This is an old school one. This is the one study, and this is another topic, but this is the one study that sort of suggested that sarcoplasmic hypertrophy was potentially something that was going on.
Okay.
So that's another aspect of this. I'm not going to focus on that for now. But in this case, they had bodybuilders with about 7 years of training on average, compared with actually they had untrained people, and they trained them for about 5-6 months. And afterwards, I think let me make sure that's the after. Yeah. So they compared after 6 months of training with the 7 years of training in their bodybuilders, and bodybuilders still had about 27% larger arms after training, although they got decent growth with that 6 months of training.
Okay.
These guys, judging by their weight, they're like 98 kilos. So when they were off season. If they dieted down, they would probably be middleweights. So their arms were like 17 inches, something like that. That's not bad for a middleweight. 17-inch arm. It's a big dude.
Yeah, that's a good arm for middleweight.
That's a good size. So that's all that data is on the bottom there, if people can see that. Up top is what happened with fibers, and this is an old study, so they're still calling them fast twitch and slow twitch, type 1, type 2. And you see the first two sets of bars there are the pre and post training for their kind of control group, their acutely trained group, who spent a half a year training. Okay. And they got decent growth. Fiber area went up in both fiber types.
Yeah.
The interesting thing, if you compare that middle set of bars, which is 6-month post-training, with the quote-unquote, they called them elite bodybuilders, with 7 years of training, their fibers are the same size. Well, how is it that the elite bodybuilders have arms that are, let's see, it's 3.5 inches bigger? If their fibers are the same size? Well, they probably have more fibers.
Oh, okay.
Yeah. So there's this hyperplastic potential that's there to get more fibers. Hypertrophy, this is why people hear me say muscle growth probably more often than hypertrophy, because hypertrophy technically means an increase in the size of the cell. In this case, muscle cells. Hyperplasia means an increase in the number of the cells. So when you measure muscle growth, when you measure fiber size, you're measuring hyperplasia. When you want to talk about how big a muscle's gotten, and you use an MRI or a CAT scan or ultrasound to measure the muscle thickness or the cross-sectional area, the volume, then you're measuring muscle growth. But you didn't measure hypertrophy. People just call it hypertrophy. They just use that term generically, but it's actually technically not correct. No big deal. But it's important because...
It sounds good. It sounds real sciencey. We're
focusing on muscle
hypertrophy.
Yeah. You'll see, but that's the thing is, like in this case, if you just looked at, here's an interpretation of that study. If they didn't make any circumference measurements, they didn't measure whole muscle size. They just made circumference measurements, and they noted in there. I don't think they even did. They did skin folds, and the skin folds were about the same. So it wasn't like the bodybuilders were really fat or something like that, which you wouldn't expect. But if you look at the post 6 months of training and compare that to 7 years of training, that suggests there was no the extra 6.5 years of training did not create any muscle hypertrophy. That's what those data say in terms of fiber. But you look at those. The one guy's got how many inches bigger arms? Like, it's obvious who the bodybuilders are and who the people are who are just half a year into training. So it does make a difference if you're looking at hypertrophy. You get much larger relative increases in fiber size than you'll typically see in muscle size, actually. You might get a 30% increase in fiber size, but the muscle only maybe gets 10% bigger. It's because not all of the muscle is just fiber. There's other things that are in there. So that's the other potential is it could be, for whatever reason, that someone is just lacking in satellite cell density in a particular muscle. And satellite cells one thing they're involved with, as I mentioned before, is increasing the number of nuclei that are available in the muscles that are getting muscle cells that are getting larger. But they also are potentially fusing to become brand new muscle fibers. So the former is hypertrophy, the latter would be hyperplasia. So if someone is limited in terms of satellite cells in a particular muscle, and they vary across, if you look at compare muscles of the eye, so we got muscles more than just biceps, triceps, quads, hamstrings. We have muscles of the eye, which are super duper fast. There's some actually other contractile proteins in some of those muscles. The muscles of the masseter, your jaw, super duper strong. There's a different myosin in there. You've got different satellite cells. Yeah, it's pretty cool.
Which makes sense.
Yeah, right. So there's potential variability in a given individual in the number of satellite cells that they have, the relative density, which is important, the relative amount of growth that you can get from those different fiber types, and the extent to which potentially, I haven't even seen this study, maybe some evidence, but if you've got satellite cells that are associated with type 2 fibers versus type 1 fibers, which of those is best, which of those populations of satellite cells is more likely to be able to contribute to hyperplasia, which seems like it could be important. This McDougall study, the one we just looked at, suggests that hyperplasia is important. So I think I've got one more figure here to go through that's kind of interesting. Yeah, this one's funny. This one's cool too. A little bit off topic, but it's the same kind of thing.
Which one? Is this one?
Yeah, that's a lot. I think it's just the third one I sent you.
This one's fiber number.
Actually, yeah, go. The one before that says female bodies. It says all weight at the very top, 2 sets of bars. Look at that one first. I can resend it if you need.
They're so small, I can't quite tell. Was this it?
There we go. Sorry.
Right.
Yeah, that's it.
Cool.
So this is a cool one. This one they compared male and female bodybuilders.
Okay.
And they've got the mean fiber area here is bigger in men than in women. So what you see in most of the studies with men and women is they get the same relative growth, percentage growth in fibers or whole muscle area.
Okay.
Women just start off with smaller fibers. They grow to the same relative percentage.
No kidding.
So they end up with smaller muscles. Yeah. So their fibers are just smaller, and you can see that there. It's pretty interesting. So women tend to have more type 1 fibers too. Yeah.
No kidding. So, I mean, I just get rid of this for just a second. Sure. I guess there's almost like you just think like women don't grow as much muscle as men, but just percentage wise, they do, is what you're telling me right now.
Yeah. Oh, yeah.
That's fascinating.
Yeah. The cool, my favorite little anecdote is that you see upper body strength. There's, substantial difference between men and women, 40, 50%.
Yeah.
Bench, you can see that although some of the best women bench pressers are getting pretty freaking close. And nothing against this, but there's probably androgen use that's involved there too. So you wonder to what extent, obviously, we're pulling these amazing athletes out of the woodwork more so now than maybe 40 years ago. But at what extent do androgens equate the playing field in terms of the fiber growth that can happen in men versus women? But women didn't have more of their muscle in the lower body, relatively speaking, than men. So if you look at body weight, even though they got more body fat, relatively speaking, if you look at muscle mass distribution and do like relative strength measurements on men versus women, so with a leg press, men and women are really, really close.
Okay.
That's why if you want to test yourself, train lower body with a woman who's in shape.
Yeah.
Because she's going to be able to hang with you weight wise pretty good, relatively speaking. And plus they've got better ability. They've got better endurance a lot of times. More type 1s helps with that, a better ability to recover. It's a whole other story there.
That would be a fun topic at some point.
Oh, yeah. We can cover that. We can get into that.
It'd be fun.
We had I did a strength testing lab back when I was university professor in Cali. And there was a guy he was kind of the star of the baseball team, actually. He's the best player. And we wanted to have a gender comparison. So he was going to be the guy to do a leg press. We had one of those really old school, like universal leg presses with the selectorized stack and the little itty bitty foot plates. You've seen those?
Oh God, yeah. I know exactly what you're talking about.
If your foot slips off, you're screwed, you know? So he was, 200 pounds at least, and she was 100 pounds. And we did the test. She was completely untrained, and he had been lifting for years. And we did the strength test, 1 rep max, and then, he lifted the whole stack or pretty close to it, and she got half the stack, and then we relativized it to body weight. She actually beat him.
No kidding.
Stronger than he was.
That's
yeah, and he was by a little bit, like 5-10%. Yeah, and he was embarrassed, like literally, and I'm like, you see this.
Yeah.
So we have that interesting phenomenon, and so now let's pull up this. This is from the same study. This last slide.
Okay.
Which is pretty cool. Our last combination of figures.
All right.
So this is an interesting one. So what they can do with they kind of made an estimate of the number of fibers an individual has, and they have fiber area which they measured, and they also measured cross-sectional area of the biceps. So let's just start at the bottom. This one's kind of the easiest one to look at. The more fibers you have, the bigger the biceps area was. So that kind of makes sense. If we think back to that other study where you had 6 months of training and 7 years of training having the same fiber sizes, but the 7-year trainees, the bodybuilders, had much bigger muscles, it means they had to have had more fibers. If their fibers were the same size, but they've got bigger muscles, they have to have more fibers. This speaks to hyperplasia. This is another piece of evidence here where the number of fibers you have correlates with the size of the biceps here. And they also found, interestingly enough, and I would look at the top here, that there was an inverse correlation between the fiber area and the fiber number. So the smaller your fibers are, the more you tended to have. It almost would suggest that there's a possibility that as you grow and get better, that the fibers might get smaller. So that's kind of an interesting thing. The bigger the area, the bigger the smaller the smaller the number of fibers. So here's and I didn't pull anything up from this. I kind of ran out of time, but you can move that that figure. So the most impressive study showing muscle growth was a study done with quail with the weighted wing studies. We talked about this one here. I think this was in our 100 to 102 series.
It's been in every 7th episode. The quail study comes up.
Yeah, the quail study. So good. I'm glad you're remembering. So the cool thing there is this is where they did progressive overload with these quails. So they had to sort of remove some of the quails from the study so they could measure the fiber size and they'll measure the muscle weight as they went through about a month's worth of this stretch overload model. So they hang a weight off the wing of the quail, and then they measure the anterior latissimus dorsi muscle. It's kind of like hanging a dumbbell off of your arm and looking to see what happens to your trap.
Yeah.
And initially, compared to the control animals, the fibers got bigger and bigger and bigger and bigger and bigger.
Right.
As the muscle got bigger and bigger and bigger. And then in the latter half, and they were doing like 2 days on, 1 day off, and added weight progressively over time. And they produced more increase in muscle size, in this case wet weight, than in any other study to date, as far as I know. They're like over 200% increase in the muscle size. So this would be like taking someone, and putting on 100 pounds of muscle in a month. You can't do that, with the whole body. But In this model, it worked because it's just that one muscle that's being stressed. So the muscle kept on growing in the second 2 weeks, the latter half, but the fibers got smaller. So fibers were getting smaller as the muscle was continuing to grow.
No kidding.
Because they were adding more fibers as they went over. So there's so many factors that are potentially involved with how a muscle grows. Do the fibers just tend to get bigger? Do the satellite cells, are they equipped better for fusing themselves and leading to hyperplasia? The loading history of the individual, is that involved? The responsiveness to androgens in terms of this. We've got males and females who just tend to have, females have smaller muscle fibers. So if we add androgens to that picture, for someone perhaps who's a male already, and now you go super physiological with androgens. They go from eugonadal to 2 grams a week. What happens there? I don't know what happens in terms of hyperplasia versus hypertrophy. Yeah. I haven't seen that teased out. So it's a very, very cool question to ask as to why that is. And the thing that people don't necessarily do is try to figure out what training is going to work best when what you've been doing isn't working for that weak muscle group.
Yeah.
And there's one other piece to this puzzle, and I've mentioned this before too, but it's kind of an important thing, is that the whole point of the weight training is to figure out how to make the adaptation into an increase in muscle size. That's like, it's sort of like you're going to have a large group of people over to your house for a party, and you've got 2 choices as to how you can accommodate that. You can go rent some chairs and get a little temporary structure to provide some shade from the sun or in case it rains. That's a cheap, quick, done easy. That's no problem. Which is equivalent to just changing the mitochondrial content or increasing the enzymes that are involved with metabolism. So when you come back and do that training stimulus again, you try to train again, you got better endurance. Instead of getting 10 reps, you get 13 because you're more equipped now energetically. That's a really down and dirty way to adapt. The larger overhaul is to go and I'm going to build an entirely new structure with plumbing and HVAC and electrical and everything else that has I'm going to build with church pews in it and seats that are permanent structures. Yeah. A permanent structure, exactly. That's what we're trying to do with hypertrophy.
Yeah.
So some people there's not non-responders to muscle growth. They just don't grow from a given stimulus that they get. We saw that in the studies where they did the 5 versus 3 or 2 times a week in the same person, and some people didn't grow from one of those training programs, but they grew from the other one, and vice versa. So, because there was likely some adaptations. I didn't see that they tested this. I don't think it's in there, but if you looked at the individuals who got no growth, let's say out of the 2 or 3 times a week training, the muscle didn't increase in size. I bet their performance went up because they're doing progressive overload in the study.
Okay, yeah.
So they got better. They could do more reps. If you took them back to the initial weight they used at the beginning of the study, they probably could have doubled the reps. So there was an adaptation there. Enzymes, fatigue resistance, more capillaries, buffering capacity, all sorts of things changed, but the muscle didn't get bigger. So you could even be someone who's in the gym, and if you're just looking at your weight and your reps, and it's everything, I keep on getting stronger, I'm just keeping it simple, this is fine, great way to do it. I've gotten better on all my exercises, and I've grown all my muscles except for the weak one. Why isn't that one growing? I don't get it. It's getting better. It may be adapting in an entirely different manner. You may have to do something completely different to get it to grow, get the cells to hypertrophy so that you get muscle growth, because it's really well equipped for that reason. And it could be for calves is a potential. Calves is a really paradoxical one potentially, because you have this situation of chronic overuse, like the compensatory hypertrophy. Your calves are growing because they've always done that. Yeah. And that was an adaptation that your muscles took on. This makes sense, And maybe that if you didn't have this locomotor pattern and you started as an adult, it wouldn't work as well.
Right.
Maybe there's an interaction, between what happened during growth and development when everything's sort of figuring out, okay, what does our environment need? That's an epigenetic phenomenon.
Yeah.
Muscle cells there will be changes in the methylation of the histones in the nuclei of those muscle cells, and probably in the satellite cells, where if they've been trained previously, the adaptations to that training occur more rapidly when you retrain after a detraining period.
Yeah.
So the cells remember. So there's something that is learned along the course of our lifetime in terms of the loading history a muscle is exposed to, that is going to give it a better proclivity to adapt to that particular stress down the road. So that person who gets better in all those exercises and their calf raises, everything goes up, and they don't get any growth, it's like that muscle may not be equipped for any of those reasons to adapt into that particular training regime. So you're going to have to find another hack to produce hypertrophy as opposed to just getting enzymatic changes.
Makes me wonder when you say, the muscle could be trained early, maybe during development to grow. I wonder about like that baby Hercules, or, you see these kids, like some little, 6-year-old Russian kid that has abs and delts and everything else. Like, I wonder what their development will be like, when they're 20. Are they doing something now that's going to permanently alter the way that their muscle will grow for the good, possibly?
He looks normal. I saw something years ago now of him, like when he was in early 20s, and
he's that baby Hercules guy grew up.
Yeah, I mean, people suspect that his parents might have been giving him some extra goods.
Yeah, I'd imagine so. Yeah, unfortunately.
Yeah. But we know that previous exposure to steroids does seem to produce a muscle memory effect where the regrowth is. So he might be a hyper responder if you were to get juiced.
I have a feeling now, if you're 6 years old and I mean you loved that at the time, but if you were kind of forced to be on that regimen, the first thing I'd want to do when I'm 20 years old is probably not do what my parents made me do to begin with. Yeah. You know what I mean? Yeah. I'd be like, I did that.
Yeah. Because he probably missed out on so much, so many things. Because it's like 6 hours of training or something like that a day. And it was something just kind of crazy. But that's what, the Eastern Bloc athletes have, Eastern Bloc, the U.S., the Russians knew this, the Soviet Union, some of the communist countries, they knew you take people who've got the kids who've got the genetic potential, and then you maximize that by getting them as early as you can in life and putting them into their training regime.
Yeah. Well, listen, what do you say? What? I was gonna change subjects.
Yeah, just my friend who she was bench pressing from the age of 6. I met her when she was in college. Yeah, she had pretty much normal strength and everything, but she could bench 275, weighing about 140.
Okay,
totally natural. She'd go into the gym into the rec center at University of Georgia, and she'd lie down and warm up with 135 for a set of 10. Guys would be rushing over thinking she doesn't know what's on the bar, and then she'd bang out 10, and then she'd train with 2 1/4.
What was her like chest and shoulder development like?
It was good. She was a swimmer and she played tennis. She ended up being a state champion in both, I believe. So like her parents were both they're both educators, both childhood development experts. Her dad has a PhD, and they knew, there's the importance of early childhood exposure to things in terms of eventual adult development. So she loved playing sports. I mean, she wasn't forced to do any of this, but so they had her, like he said, well, she's got to do some upper body strength. He was an exercise physiologist. Like, she's got to do some upper body strengthening. So she just started bench pressing. They go for their morning runs or whatever as general conditioning. Yeah. And they come home and he had a bench press in the garage, and she just, I don't know what she did, like, a few sets of bench press, but from the age of 6.
Yeah.
And so she developed that neurological pattern. It was just a groove. She used to, they like had her play a game. It was called Math Blaster. was like on like one of the old, old computers. It was kind of like a Space Invaders game, but you had to like do the math really fast in your head.
Yeah, yeah.
And now she has a PhD in molecular biology.
Okay.
I don't think she was on the podcast, but she scored a perfect score on her SAT, I think, when she was 13.
Holy shit.
Or maybe she was 15. Yeah.
So she's a genius.
They drilled her for that.
Yeah.
They drilled her for that. Yeah. But she's not like people with that level of intelligence or with those types of test scores. You're like okay, like your head's working at a totally different level than mine. Like I don't have any idea what's going on up in there. You're like 5 steps ahead of me. Speaking of geniuses, yeah, your household genius there.
Yes, she came by to drop off my shaker cup. Thank you, dear.
So yeah, there's something to say. So yeah, you may, you don't. I guess I wouldn't give up if you think you miss your window of your childhood window of opportunity in terms of muscle growth, but you got to think outside the box, and that's what a lot of times people with great physiques have never had to do, so they don't do it. Talk to friends who've got, you've probably seen this, some of the best athletes they've gotten all the way they've gotten just kind of doing kind of whatever, and then they haven't developed the problem solving skills
absolutely
that you and I have. So that's why those muscle groups may stay weak. They just keep doing what they've been doing, and they keep getting what they've been getting, which is not an improvement in the weak muscle groups.
Yeah,
because they haven't figured out a novel strategy.
Remember, it was rumored that Arnold got calf implants, which I'm guessing probably didn't happen. But maybe, maybe he figured something out, because there was a point he didn't have calves, and then he came back and he had calves. So,
yeah, I always said it was that he cut off all of his pants.
Yeah. Yeah.
So he had to look at his calves all the time, I don't know. What I've never seen is, and you think someone would have done this as a before and after on his calves.
You would think, somebody did somewhere. Somebody has somewhere.
Okay. Yeah.
If you're in the Facebook group, the Think Big Facebook group, and you want to do one for us, we'd love to see the before and after of Arnold without good calves and Arnold with good calves.
Yeah. Yep. I would like to see that too.
All right. Well, listen, we've got a few of them here. Let me see what we can dig up here. And I know we had one in the live feed. Anybody who wants to drop anything in the live feed, feel free. All right. So here's one, Clen and cramps. He says, is this nervous system overstimulation, and what are ways to fix it? So we talked all about clenbuterol. By the way, we got a lot of really good feedback on that episode. Thank you, everybody who had commented on that one. And I think that was a really good episode, Scott. It was great science, and you broke it down in a real simple way that was easy to understand. I think a lot of people connected. Yeah,
I got that impression too. People were digging it. So Clen can produce a moderate, at least, hypokalemia, so low potassium levels in the blood. Cramps are generally thought to be a function of what's going on in the nerves that innervate the muscles. So it's some sort of electrolyte dehydration issue that causes, eases depolarization in those nerves. So they tell the muscles to contract more easily, and that's what you have when you have a cramp.
Yeah.
Or something like a cramp. So taurine is the best anti-cramp supplement I know of. It's awesome for that. It works really, really well. A little bit of potassium is not a bad idea necessarily if you're getting, like, this is why people say have some bananas, because bananas are high in potassium. It tends to work. I tend to suggest people just take a multi-mineral, which has potassium in it. You don't want to take in a bunch of potassium. The 99 milligram potassium pills that you see, that's what it typically is dosed at, is because it's like 1%. One pill's like 1% of your RDA or RDI. Because if you take too much potassium, you can cause too high or too low. You can cause heart arrhythmias, and it's not something anyone wants. So there's tonic water. It's a quinine and tonic water. It's a possibility.
Yeah.
And just drinking more fluid. So that gives your kidneys a better opportunity to make sure that that your electrolyte levels are where they should be.
Yeah.
So, but you can dehydrate yourself. You can dilute the kalium or the potassium even more.
Yeah,
if
you got to
do that.
keep
So
you got to keep
watch out.
the electrolytes and everything up if you're drinking more water. I had a couple things I wanted to mention. One, I just told the guys on Blood, Sweat, and Gear the other week, we were talking about quinine, and I ran an experiment where I kept tonic water next to my bed. I would get calf cramps all the time when I was prepping, and I was on higher doses of Clen, and I'd wake up and I'd drink like some salt water real quick to fix it. And then I wanted to see, well, will the quinine work? So, will the tonic water work? Instantly, Scott, like I would get the cramps where like you couldn't even stand up, because it was just so bad, and took a drink, and literally within seconds it relaxed. So it's crazy how fast that worked.
There's a study. So people have used pickle juice too. High in sodium.
Yeah. And
there's a particular study where pickle juice literally had that exact same immediate effect. And it was before there was any noticeable change in the sodium levels in the blood. There's some sensing mechanism. There's some osmosensing mechanism that is probably reacting to fluid intake. Some of it's maybe unconscious. Some of it maybe it's totally conscious. That's at work here. So you can literally just have the pickle juice in your mouth, and you'll get the effect on reducing the cramps, reducing the electrical activity in the cramping muscle. So yeah, they've done there's mouth rinsing experiments showing that just rinsing your mouth with a sweet carbohydrate solution can have ergogenic effects. You don't take in the carbs, you don't swallow it. You don't get any carbs. There's no fuel that's coming from what you put in your mouth because you spit it back out. But it'll have that impact. And I've done this a couple times to people when I've been at shows backstage with someone, when after they come off and they haven't had water for a while, because it happened to me all the time. I always know it. So you go and you woke up, you did everything, you dried yourself out right, your pee is just dribbling, and then you haven't peed for 4 hours. It's you finally get all done, you can drink all you want. So you got your bottle of water that you brought along, so you'd have something to drink when you're done, and you drink. Literally, you're halfway through. Oh fuck! I gotta pee right now.
Yeah.
The urgency to urinate happens instantly.
Yeah.
I remember saying to someone, "Hey, where's my water?" I said, just pay attention to this. I said, I'm not trying to put it in your mind, but you got to pee right now? No. Okay. And then they take a drink. It's I gotta pee. How did you know it was gonna happen? I'm because it happens to me all the time.
Yeah.
So it's pretty cool. And that's a really how did this particular it's like a reflex essentially has developed. I think that fits the definition of a reflexive physiological phenomenon, because it's just getting into your mouth you're drinking it. It's like the quinine hasn't had an effect. It's not had the chance to reach your neurons or anything. It's just there.
Yeah.
So some of it could be purely psychological because you're taking something, but happens with the pickle juice, happens when people just drink water and they're sense to urinate. So something about how how our nervous system senses our hydration state and our electrolyte state is very acutely sensed with this reflex phenomenon or phenomena. There's probably many of them.
Yeah.
So I think that's kind of cool. I haven't seen it really explored anywhere except for that one pickle juice study.
With the water and peeing thing, I think that's a great tool in contest prep when you're trying to get dry. You know what I mean? You can, I think that's one of the reasons, you can drink a little bit of water and it'll stimulate you to keep peeing too.
Yeah. Some people, I haven't really done that so well because I employ so many other things, but you just got to be careful unless you're measuring it. You can end up drinking as much as you're peeing and you don't progress anywhere. Sure. Yeah.
I've used that, but keeping water in and then gradually reducing it, but making sure that you keep it in and then, check on people hey, when we check back in an hour with new pictures and let me know how many times you pee between now and then. And we can kind of, The other thing I was going to mention to you was just a random thought I was having, and it's interesting. I think Andrew Barry was having kind of a similar thought so I was looking into some stuff about taurine, and I saw that low taurine, there's a relationship to low taurine and heart issues. And and I know that Clen depletes taurine, from what I understand. So I know that if I keep taurine in the system, I know that that's going to help to keep me from cramping on Clen. And I know that Clen can also be bad for your heart. I wonder, is there a relationship to the fact that it depletes taurine if low taurine in your heart causes heart issues?
Yeah, my suspicion is related to free radical production.
Okay.
Taurine is a really, really good antioxidant, actually. There's another study showing that in rats, it prevented nandrolone toxicity in the gonads.
Taurine did?
Of these rats. Taurine did, yeah. So it's got free radical quenching abilities. And your heart is the penultimate penultimate oxygen user, but that also means produce lots of superoxide radicals. So every time when you're in the process of aerobic respiration, oxidative phosphorylation, it's a great term. So you're using oxygen and it's going through the electron transport chain, and it's basically this scenario where it's kind of like letting water flow through a dam. So you're harnessing the potential energy of that water to turn the turbines and produce energy. You let these electrons flow through, you create a proton gradient, and what happens at the end there is the water and hydrogens combine with electrons, the oxygen and hydrogens combine with electrons, and you get water. But every once in a while, 1, 2, 3, 4, 5% of the time, instead of having water produced, you get an electron loaded onto an oxygen molecule, and you produce a superoxide radical, and that's a free radical. So that free radical it's like a radical, like person's radical. It goes and then it will damage other molecules. This is what free radical damage is all about. So the heart, because it's producing so much energy, it's constantly going. It's producing lots of free radicals. So its antioxidant status is very important. So if Clen is going to substantially reduce the antioxidant status, plus it's increasing the oxidative phosphorylation. It's going to act. It's a sympathomimetic. It's activating your heart. Your heart rate goes up, potentially your blood pressure too. So it's producing more free radicals and then reducing your ability to quench those just by virtue of reducing taurine status in the heart cells. So you've got the damage of free radicals there that is there.
Yeah, just a random kind of side thought.
Yeah, no, taurine's great. Taurine's a great, very, very worthwhile supplement.
I've worked it into my daily plan now. I used to just use it, at during times I was using Clen or times that I thought I might cramp, stuff like that. But now it's part of my regular go-to.
I can see your coffee in the morning where you've got the 30 grams of the collagen, and then you add like 5 grams of creatine, and then because creatine doesn't taste like anything, and then you add 5 grams of taurine, and you just have like a mountain of white powder with a little bit of coffee mixed in. It's like a coffee powder sludge.
Mix some MCT in there. That's the new thing. Or several years ago, people started doing that. The bulletproof coffee. It'd be good to go. All right, so here's another real sciencey one for you, Scott. Talking back about, so this once again relates to the last episode. We were talking about P450. So does using that supplement that inhibits P450 increase stress on the liver? Is there any difference at all? By the sounds of its effectiveness, when all gear users, even with injectables, should be using this product to increase the active life of the drug administered, assuming he or she is not using any other chemicals that need that metabolism factor. So I think, one thing I think would be really interesting, and we kind of mentioned this, I asked you before the show, to talk about would be like, what is the P450 pathway?
Yeah, so the liver has, kind of simplified, to sort of 2 phases that are involved with detoxifying xenobiotics, so foreign chemicals, which are drugs or toxins or things that aren't produced in your body that come from the outside. And the first involves these P450 enzymes, these cytochrome enzymes. And what those do is there's oodles and oodles of thousands. Oodles is a very technical term. Thousands and thousands of these, and they some of them are used very generically, and some of them are used more specific. But these modify and involves electrons. Actually, modifies the xenobiotic, the drug. Let's in this case, so that it can then be conjugated with something and gotten rid of. So it's sort of like, imagine someone comes in your house and you got people coming through your house, your business all the time, who you may have to have chauffeured out. So the first thing you need to do is make sure that the people who are monitoring your door to get rid of these unsavory characters can take them out easily. So that's what the P450 enzymes does. It modifies them so then they can be conjugated by your bodyguards, and then once they're conjugated, they can be lost in the stool or excreted from the body.
Okay.
So the first phase 1 is the P450 enzymes, and phase 2 is conjugation of some sort, and there are various ways that can happen. Glucuronidation or sulfation. There's actually differences there that are involved with anabolic steroid metabolism. So the problem is that phase 1 produces free radicals, and those are toxic. So that's why almost all of your liver supplements, things like alpha lipoic acid or acetyl L-cysteine, or the herbs in Liv 52, those are all have free radical quenching abilities. Either they turn on the enzymes that are involved with free radical quenching, or they are antioxidants in and of themselves. So here's the thing. As far as penultimate damage to the liver, it's probably going to depend on the person and the drug, because oftentimes there's multiple pathways. I actually have a I can send this to you. Why not? I think I have it here available.
Ah, cool.
I think. Yeah, let me pull it up right now. It's on PowerPoint. So I was putting together a presentation. We talked about this on tamoxifen, Nolvadex.
Yes. Yeah, I'm interested to hear about that.
Yeah, I got to put together my my medical waiver type of thing. Let's see. Let me just send this. This is just an example, one that I just knew I had fresh. I'm going to text this to you, Scott.
All right.
It's fucking crazy.
Ooh, look at this.
So true. Yeah, it's nifty, huh?
Ooh. Let me know if you. Yeah, let me know if I love these things. Let me know if you want me to zoom in on any part in particular.
So yeah, that bottom circle, we can just move that out. If you can zoom in on the kind of the upper left, bring it back down. You can see tamoxifen is at the top there. Yeah.
All right.
So those where it says SIP there, those are all P450 enzymes. And what you can see is that, like, for instance, if you look at tamoxifen in the center there and it goes to 4-hydroxytamoxifen,
Okay.
those are all P450 enzymes that can do that.
Okay.
They can make that conversion. And there's one, for instance, like the CYP3A4, that is involved with tamoxifen to 4-hydroxytamoxifen.
Yeah, I see.
And then 4-hydroxytamoxifen to endoxifen. It's also involved with tamoxifen to desmethyltamoxifen. So it's involved with multiple pathways. So if you inhibit that one, for instance, someone is going to have to rely on other enzymes.
Okay.
For metabolism. You may completely block or just slow metabolism, or you may end up changing the pathway. So if you cut off water's flowing down a mountainside, it's got multiple streamlets that it's in. You block one, more water is going to flow down the other ones. So depending on what you do and which drugs the person might have in their system, and the isoforms of these particular cytochromes, these P450 enzymes. For instance, the one that I think it's a CYP3A4. Let me check. I can double check and see what I wrote in my. Yeah, no, it's a CYP2D6.
Okay.
So you can see that one right there next to tamoxifen, right to the right of it, CYP2D6.
Okay.
That one's involved with all those same places as CYP3A4 is, pretty much.
Okay.
So that's one. There are at least 100 polymorphisms of that enzyme.
Yeah.
That have been identified. That means there are 100 different versions of that enzyme that someone could have. So, depending on the relative activity of that enzyme and the other in the CYP3A4, and the person and the drug, you could change the metabolites that are produced and change the drug and end up producing different fluxes in free radicals and end up causing more or less damage to the liver, depending on what pathways of detoxification are followed in terms of creating something that can then be lost by the system. So in this case, like all these metabolites here,
yeah,
like the endoxifen, this I'm just kind of jumping ahead, but tamoxifen doesn't really have binding affinity to the estrogen receptor. It's endoxifen that does.
No kidding. So it turns into something else that binds.
Yeah. Endoxifen is the main one. I think it's 4-hydroxytamoxifen. Both of those have, but endoxifen is considered the main actual SERM. If you can slide that thing up a little bit, you see that endoxifen is an arrow that goes kind of the bottom left and it arches all the way down to norendoxifen.
Okay. Yeah.
Norendoxifen, and here's the question that I'm still kind of digging into because I haven't found this. It may not even be out there yet. But norendoxifen, if you compare its anti-aromatase activity, it's on par with that of letrozole.
Really?
Yeah. Now, so that's the thing.
Huh.
Go ahead.
Oh, well, I just wanted to see where that went. So that's the cell.
Yeah, that's the target cells. Yeah, antioxidant.
This is really cool. I can get with these things. Like I can read this. You know what I mean?
Okay, good. I'm glad. Yeah. So that's the interesting thing is like, so the effectiveness of tamoxifen is going to be a function of how much endoxifen you produce.
Yeah.
And its impact on estrogen production is going to be a function of how much endoxifen is produced, which is it's demethylated there. I think there are multiple pathways for that. Okay. And so, and you can see there's multiple pathways to produce tamoxifen to endoxifen. It can go through the 4-hydroxytamoxifen pathway on the right, or it can go to the left and end up there as well.
Okay.
So that's an example. There's actually another study. I've got this all in this thing that I plan on putting out as soon as I get done with it. In actually pre and both postmenopausal women, and they found that basically in about 1/3 of those individuals, estrogen levels went up when they were taking tamoxifen.
Really?
But in the others, it's just stayed low. So something's going on there. They may be producing you would expect that if you block estrogen, just thinking in a very basic negative feedback loop way, if you block estrogen, then the body would produce more of it because it senses that it's not there. I mean, that's why people use SERMs in men. You block the negative feedback of estrogen and you get more testosterone. Yeah. Because estrogen levels are representative of testosterone levels. So in those women, for instance, who had elevated levels of estrogen after they took tamoxifen, which didn't happen in 2/3 of the women in this particular study, it may be that's a normal response to blocking the estrogen, and they just, for whatever reason, don't produce much of the norendoxifen, which is the AI. So their elevated estrogen levels, they had elevated estrogen levels because they didn't have norendoxifen being produced substantially. But that's kind of unknown. So, but the interesting thing is that the resultant estrogen levels were substantially different in that 1/3 of individuals. So that's very cool.
That's fascinating to me. And it's fascinating. Yeah. I mean, just to bring that back up here for a second, it's fascinating to me. So it's not that simple, number one, that you take tamoxifen and, that's just what you picture in your head. I'm looking at this whole web. So tamoxifen turns into all these different boxes. It's so far from what I think. Like, I think oh, I take Nolvadex and it breaks down to my stomach, it absorbs into my bloodstream, and then it goes to the estrogen cells, or estrogen sites. It's so much more complex than that. And it makes me think, too, that if we're messing around with this, like, hey, I want to take this supplement that's going to interfere with the P450 pathway, like, that's interfering with a whole lot of stuff, I'd have to think then. What about internal stuff, like things that we're already exogenously producing? That would be like a whole cascade of things we're altering then.
Would be a major wrench in the works potentially.
Yeah.
I mean, tamoxifen is really a prodrug according to this, because it's an endoxifen. It's like a prohormone where the prohormone doesn't have any implicit activity.
Yeah.
So it's acting as a prodrug. So you need to have conversion to get the effects, and not all women who have breast cancer get an effect from tamoxifen. It doesn't work universally for everyone. And you can imagine why when you look at all these enzymes that are involved. Yeah.
So I'm going to bring that question back up now that we've done this education. He says, does using that supplement that inhibits the P450 increase stress on the liver? Is there any difference at all? By sounds of its evidence, then all gear users, even with injectables, should be using this product to increase the active life of the drug being administered.
So that would depend, like I said, on the drug and how you change the metabolism of that drug and what that means in terms of how many steps those metabolites have to go through before they can leave the body.
Yeah.
So you may have levels of those metabolites along much longer. Depends on your free radical status in the liver too. So. Yeah. I have to go and look, and probably could find this, but I don't know to what extent a given molecule or type of molecule must be removed in that phase 2. So let's say this is purely like kind of an armchair, a wild ass guessing here, but let's say that for a particular metabolite, it could either be sulfated or gluconated. So you got a glucose or it's like a glucose moiety to it, or a sulfate moiety, and then it can be taken out. So those are the bodyguards, or the people who escort the unwanted, the unsavory characters out of the house. So you got two options there, and let's say for whatever reason, someone one of those is not very available, but that particular metabolite needs to be escorted out through that mechanism. And so this individual, when they take one of these hesperidin or naringin, they create more of that particular metabolite, which they lack the ability to rid the body of. And then that sends that metabolite off into other pathways that produce more free radicals because of the continued activity of the P450s. So you actually increase P450 activity, increase free radical stress, because you've changed the metabolism that would normally be, maybe even for that individual, a very simple, not terribly stressful situation, because now those metabolites, they don't get out. They're not rid from the body because of that person's genetic abilities to do so with the new metabolites that are formed. So it's like, another simple analogy. You could take a one wheel, or you could take a bicycle, or you could take a unicycle, or you could walk, or you could run. There's various ways to get from point A to point B. And if someone's used to being a bicyclist, and you say, okay, now get on this unicycle. Some people, like I'm like, yeah, I can ride a unicycle just as fast as a bicycle. I rode a unicycle when I was growing up. Some people are like, all I do is fall flat on my face. I can't ride a unicycle. Unicycle is not going to work for me.
Yeah.
Metabolically speaking, you're changing the mode of transport for removal of those metabolites from those xenobiotic toxins, or what the body is basically considering toxins, those drugs from the body, in a way that could be more toxic potentially. But it's situational. You can't say all or none. So that's hard. It's hard to know. And I've looked. It's not like in this case with tamoxifen, because that's the nice thing about a drug that's been effective against cancer. You get lots of money to study that. Yeah. It's funny. People say, and I get why they say this, is like, we don't want to cure cancer because it's too much of a moneymaker. But you can imagine the number of research studies that went into figuring out those metabolic pathways.
Oh,
like that's
I
a
can
lot.
Only imagine.
Yeah, crazy, right?
Yeah.
So we don't see that when it comes to hey, how can we increase the half-life of Dianabol so bodybuilders can get bigger? You don't see that stuff on anabolic steroids because they don't have the medical applications that anti-cancer drugs do.
Yeah.
So we don't know those P450 enzymes. We don't know those pathways in and out. We don't have specific inhibitors that lead us into pathways that are less toxic, but also prolong the active state, the active half-life of a given drug in a way that would make that drug more effective.
That makes so much sense, that we do have the ability. If we were interested in figuring it out, they could figure out so much more. Yeah, on Planet Meathead. Yeah.
I'm going to make me president of Planet Meathead. Then that's what we're doing. Keeping bodybuilders safe first and foremost.
Yeah.
But yeah, absolutely.
All right, I got one here in the live feed from Tim. He says, "Hey gents, can you talk about the difference between muscle fatigue and failure?"
So. Here's the thing. People have started using the term fatigue in different ways in the last decade or so.
Okay.
So muscle fatigue, just sort of the classical definition, is it's the relative amount of force, typically force that can be produced at a given state, and just you can leave it at that. Actually, so if during the course of an exercise bout, your maximal force production is reduced by 50%, then that's your marker of fatigue. Some people talk about fatigue as your relative kind of recovery state, like you still have accrued fatigue. So you train on a Monday, and if you try to go in and do the same exercises on Tuesday, then you're not going to be as strong because you've got muscle damage involved. So fatigue in the classic sense, the way I've typically thought of it, is a function of acute inability of the muscle to produce force or power, or to maintain a power output due to metabolic fatigue byproducts and or some function of the nervous system or the brain. Yeah. So you're psychologically fatigued. It just hurts too much. I can't do it. There's various loci of fatigue, everything from the black box in here, the central governor, your brain, to the motor neurons there in your motor cortex that produce the movement patterns, to the neuromuscular junction, potential fatigue in the depolarization waves that happen in skeletal muscle cells when they produce force. Then there's the acidity potentially, that changes the activity of glycolytic enzymes and changes the shape of myosin. So you maybe don't get as much power or work produced when you break down ATP, so you lose efficiency. There's everything from the beginning to the end is potential side of fatigue. And that happens, the higher your work output, the greater your fatigue is going to be.
Yeah.
Now the next question is, what causes muscle failure? And that's, momentary muscular failure is typically thought of as that's the inability to maintain a force output or maintain a rate of work production. So moving 100-pound weight back and forth, eventually you reach a point where you're incapable of doing that, and that would be muscular failure. You could break that down into concentric failure or eccentric failure. So ability to do another concentric repetition. That's why you can do force negatives. A lot of those, actually, if you really want to kill yourself, you can do 10 reps and then your partners lift the weight up. You can get 3 or 4 more because you've got greater efficiency or economy with eccentrics and more force produced with eccentric contractions than concentric. So, but the limiter on failure for most people, I think, is up here in terms of motivation.
I would say
and
that.
Having learned to push. There's there's the studies that we talked about these, where they take, go to estimate your reps in reserve, and people say 2 or 3 and they're off by 10. You just tell them, get more. Yeah.
So would you say then that, so muscle failure, are you saying that is that failure, that's not failure of the muscle then is what you're telling me? Yeah.
I mean, in a research study, failure is also, I got to add this just to kind of complete the idea here, is that it's maintaining that work output. If you're talking about doing reps of resistance exercise with appropriate form and on a particular tempo. So in a controlled situation. So like you could keep going and then just make a widowmaker out of it. Like, you want me to do knee extensions? Okay. How many days can I go? I'll just sit in the machine and I won't stop. I didn't fail, right? My set's not over until I get off the machine, right? So, but you failed. You're waiting 30 seconds between your reps, and it's just pure willpower.
Yeah.
So there's that. But so failure, I think you answer your question. A lot of it is potentially in the brain, in motivation and all the inhibitory feedback that comes back to us, that it hurts. And then, all the hidden psychology as to why we just don't want to push ourselves to the point where we're potentially injuring ourselves.
Somebody commented on YouTube or on one of my Facebook posts. It was Dusty. Dusty had said something in the show about training to failure, and somebody's comment was that nobody trains to failure. That training to failure would be that the muscle tore or was near tearing. What do you think about that?
Well, that's not true, because most people aren't doing sets with maximal loads. I mean, why a muscle tears when it does, like, you have all sorts of muscle tears when people are doing just minimal things, odd things, really light weights, or like guys, like they step down they take a wrong step walking down a ramp or getting out of their truck or whatever, and they tear a muscle. And that could potentially be because it's an odd situation and they have a really unusual activation pattern, and it creates force inequalities across a muscle that leads to a tear in one place. And once it starts to tear, it's kind of like the yellow pages, the strongman trick, getting the yellow pages to tear. And the trick there is getting it started. And once it starts to go, it just goes.
Okay.
So you can have a muscle tear with a very light load. I'm going somewhere with this.
Yeah.
But most of the time, if you're doing a set of 10 or 15 reps, what's that?
You always do. You said, I'm going somewhere with
I
this.
always do. Yeah. Every once in a while I lose my way, but usually I come back. But if you get to the end of your set and you're using 75% of your 1 rep max, it's not like the forces are higher than the muscle could possibly tolerate.
Yeah.
Because you just did 12 reps before the 13th one when you're incapable of producing another rep. Now, a muscle tear would also be one potential cause of muscle failure.
It would fail,
right? The muscle, literally, that's a complete mechanical failure of the muscle. Like, there's no muscle left that's connected from tendon to tendon because you tore the thing. Yes, but it depends on the exercise too. Here's the thing, just make this sciencey, maybe in a way that other people, because Dusty, I think I saw Dusty's answer to it. And his
I don't even think Dusty saw it.
Oh, okay.
Yeah.
No, Dusty's, like, when he addressed it though on the podcast.
Oh yeah,
talking about like
going to failure.
Training, 10 years ago or 20 years ago, he couldn't do what he now can do. You learn what you're capable of. By training with people who train harder than you, or just having those crazy training sessions, your bar incrementally goes up and up and up. And what seems like at some point, like, that was just kind of a so-so training session, 15 or 20 years ago, be like, holy fuck, I killed it, baby. Like, that was amazing.
Yeah.
But relative to where you've been. But here's the interesting thing. There's a way that they've assessed like motor unit activation. So if someone were at true muscular failure, what you would expect from a neurological standpoint is that they are fully, maximally activating all of the potential motor units that are available. So motor units, the nerve and the fibers that are connected to it. So there's nothing left. It's like if you end your set and you're not like really at 100% activation, then you got more reps in reserve. You got more reps in the tank. So they can test this in various ways, but it's basically the same methodology. They can activate the nerve or they can activate the muscle with electrical stimulation. So usually like a knee extension is the easiest one to kind of describe. It's how it's usually done. So you put someone on a knee extension machine and you turn up, you put pads on their quad to activate a good volume of the quad, and you figure out how much juice you got to give in order to turn on and get like 25% of the muscle force that they can produce voluntarily. Right? So let's say they can produce 1,000 newtons of force on a dynamometer, and you get up to 250 on that. So that's activating, let's say, roughly 25% of the muscle mass. So then you say, okay, now I want you, the test subject, to push as hard as you can, and then you turn on the juice. And if they're already activating those motor units, then when you turn on the juice, you'll get no more force production.
Yeah.
They've already activated them.
Yeah.
Well, what happens with people, and this is the problem with the phenomenon, here's a couple problems with this way of doing things, is that, we did this back when I was in grad school, and you see this in some of the studies. You turn on the juice, and the electrical current or the depolarization wave, it goes both ways. It goes down to the fibers and would turn them on if they're not already on. It also goes back up. It goes back up in the direction of where the signal's coming down from your brain. So it's like two waves colliding, and what do you get? They cancel one another.
No kidding.
So the force goes down.
Huh.
So I'm pushing 1,000 newtons or whatever Newton meters, and the force actually will go down because you're colliding with the waves coming down from the brain with these. They're called antidromic waves. So you cancel one another, your force goes down. So it's like, oh, okay. Well, what does that mean? Like I was activating 120% of the motor units that were available there.
Yeah.
It means that the method can't be used to test this, but they still do it. It's been done. I don't know how much it's done. I haven't read a study for a long while that did, but for years and years they would do this motor unit activation, et cetera, et cetera. And they do studies, for instance, there's a study with older folks where they use this same testing methodology. These were like 65-year-old people who were totally untrained. And their claim was that they were able to fully activate the quads.
Okay.
It's like, well, we know you take an untrained person, regardless of how old they are, they get strong really fast.
Yeah.
You take an untrained older person, first time you bring them in, and they get strong even faster in many cases.
Really? Okay.
There have been studies with 90-year-olds, who like there's a kind of a classic study by Maria Friadaroni from like 1989 or 92 or something. And they increased their strength by like 200%.
No kidding. Wow.
Over the course of just doing knee extensions.
Huh.
So because you're untrained, like you're untrained and you've also got sort of disuse. You don't know what you're doing. You haven't done anything of, relatively high exertion for a long time.
Yeah.
So you really can't tell, but we know that if you take most people and they're still making neurological gains, then there's something going on. It's not just whether the motor units are on or off. There's something about the coordination there, the rate coding it's called, of the firing rate and the way in which the motor units are activated in order to produce more force that is contributing to their force production. So if you're continually making gains, there's something that's missing there. You've not got full activation. But I think most people who train really, really, if most people don't, I go into most gyms, I hardly ever see anyone who I look at and I say, I can't remember the last time I did. I was like, well, I want to train with that person. because you don't see people like going after it. It depends on the gym you go to, of course.
Yeah.
But it's very rare because it's a really kind of a bizarre and it's only socially acceptable in gyms, in certain gyms especially, to train that hard.
Gyms. Yeah.
You know? People just don't want to do it because it friggin' hurts. And you have to be a little bit, you got to have some loose screws bouncing around up top to do that. So
in the best way.
So
yeah.
Yeah. So, but failure, here's the thing to relativize this: failure is failure for that person. You know, that's when their system failed, and under those circumstances. Yeah. Now you can invalidate the psychometric of reps in reserve as a stable, reliable psychometric measurement, because what you can do then is bring someone, you know, bring in the researchers, or bring in the big guys, or bring in a trainer, or, you know, have them train with someone like where they want, like holy shit, like this can be great for a guy who trains with a woman who's got better endurance and recovery. Like he's not going to let her beat him. Yeah. So you know, so he's got to hold on to his balls during this. He's got to train hard. He's got to hang in there. Or you've got a researcher who says, okay, give me 3 more. Or you've got Tom Platz who says, give me 5 more, like we talked about before.
Yeah.
So that relative failure, you know, it's a function of the circumstances and the individual and what have you. And it's a function of what your willingness is in most cases, in many cases, what you're willing to actually put yourself through. But you can standardize that in a research setting when you're talking about muscle failure by using a tempo and forcing the individual to maintain the tempo. This is why I kind of do this in Fortitude Training in part, which there's kind of story. But compare a Widowmaker with a pump set. Pump sets, the reps are continuous. I limit intentionally how much you can just dig in and do those grinding reps, because that can create. Then that becomes with an advanced person a test of their willpower, and they'll eat up their recovery reserves doing that.
Yeah.
Because they can get 5-10 more reps just by like when you first time you did a muscle round with that standing squat, and you just were like you were taking a break between every rep because you just wanted to go as heavy as you could, you know. And I did the same thing the first time I did Leo Costa's Titan training with his muscle rounds. It was crazy what I did, you know, but I just wanted to train as hard as possible. So in a research setting, you can say this is a tempo you need to maintain. If they're unable to maintain the tempo, then they reach failure. So that's the work output or the power output or the constraints of the workload that is part of the training protocol. So you can reach failure where, and sometimes it's kind of like this, depending on the muscle and its fatigue. You train a small muscle that for whatever reason you don't have great fatigue resistance in. Yeah. Like let's say one arm biceps, and like you go and you're like trying to stay on the tempo, and it's like, okay, I couldn't stay the tempo, so the set's over. Yeah. That's failure. Yeah. That's how it's defined in that situation. But like it was just one biceps. That was nothing. It didn't. I'm not like on the ground thinking, oh my God, like I've gone to hell and back. Right. It was just a unilateral biceps curl, but you reached failure. Yeah. You do that. Now take a squat Widowmaker where it's like, no, I want to see like ultimate failure, you know, or whatever it is, where there's not a rep left in your system, no matter if you got a gun to your head or your family's life is at stake or you're going to win $1 million or whatever it might be. There's no way you're getting another rep. It's just an absolute impossibility. Well, that's failure under those circumstances where you allow rest in between the reps and what have you. So you have to control for those things in training studies, because otherwise you this disparity between people's willingness to go to extraordinary extent to just fucking decimate the muscle, and they like to train hard, will create a huge gap in what the actual training stimulus is. You have one person who just goes like, okay, that hurts, I'm done. It's like, the reps didn't even slow down. Lyle McDonald's got some hilarious videos when he and Mike Israetel were going back and forth. People probably remember this a couple of years ago. And talking about like what happens when you maintain a rep tempo like that is you see a reduction in the bar speed or the tempo. And you can see like the reps, you know, like the last rep is maybe 4 seconds when previously it was 1.5 or 2 on the constant. It's like, okay, that makes, and once you get to like 4, like 1, 2, 3, 4, and you come back down again, it's like that next one's probably not going up unless you stop, put the bar down or whatever.
Yeah.
So like Lyle does like an analysis of that, and he actually, times the reps to show. And that's another, nice metric to show that you've evoked a certain requisite amount of fatigue that you could equate to reaching failure, so to speak, or you could use as a way of standardizing the stimulus of the set based on the constraints of the rep tempo and things that you've set in there. Because if you just let people do willy-nilly Widowmakers, some people are like that story I told about the guy I trained with. Like, I did my Widowmaker, and he's like, I'm not doing that. We're done. And he never trained with me again. Which is just like they'll never do a real Widowmaker because they don't want to do that.
Yeah.
And other people are like, you want me to do another one? Mofo. Okay, I'll do that. Like, you ain't beating me. No way, no how today, never. Yeah. And they'll do it. They'll go till they die,
Right.
So you got to constrain those things if you want to equate the stimulus and take the brain out of the picture to some degree, at least. So
right on. All right.
Great topic though.
Listen, let's wrap this thing up. Guys, go to BYOBB. Let me try that again. Go to BYOBBcoach.com. You can get Scott's book there, Be Your Own Bodybuilding Coach. And check out our great sponsors too, TrueNutrition.com. Use our code THINK over there. Go to supplementsource.ca if you're in Canada. And for those of you at Patreon that are helping to support the show, thank you guys very much. And if you're interested, every $5 helps. I will have links to that down below. Scott, as always, man, it has been a pleasure. And I'll look forward to hearing more about tamoxifen as that unfolds.
Yeah, will do, man.